All right, doing the math on a VT graph, uh, just to show you the full effect. So I've tried to say VT graphs are more powerful because we can get all three pieces of information about the velocity. From a VT graph, we can get the actual velocity, which may sound a little bit silly, but we can just read the graph. So for this one, and if you looked at the chart, I kind of put it up top in the chart, we know the velocities. We know this object started from rest, because it started at the origin. It's got a line with a positive slope, so that means it accelerated. It got to this point before it stopped accelerating, so it accelerated to, that's a value of 8 meters per second, and then it just cruised at 8 meters per second. If we look at the bottom, the scale goes up by 2. So this is a 2-second mark, so 2, 4, 6, 8, 10. So from 2 seconds to 10 seconds, it was going 8. So we could say that 2 to 10 seconds, that's a time of 8 seconds. So that's the velocity information we can get. I've also said we can get the acceleration information. Acceleration is equal to the slope. In this case, it accelerated for this part of it. So that purple line, we need to get the slope of that. So A is slope, slope is always rise over run. In this case, it went from 0 all the way to 8, and the run was 2 seconds. So our acceleration has a value of 4. Now here's a weird thing that I kind of glossed over, perhaps a little bit too fast, or doesn't make sense when we type it. The rise units are meters per second. The run units are seconds. So we get this funny unit of meters per second per second. The seconds don't cancel out in this. You could like work through the math and do an invert and multiply, but we end up with the seconds combining to make seconds squared. So we're going to write that as meters per second squared. That's the funny unit for acceleration. If we didn't see the math, if someone said to us, hey, that car accelerated at 4 meters per second squared, what that means is that every single second it was accelerating, it got faster by a value of 4. Every second, it increased by 4. That's kind of telling us how our slope looks. It's just a funny unit. The third part of VT graphs that, again, maybe I didn't talk through enough, is we can get displacement information by looking at the area bound by the curve. It's kind of a calculus thing. It'll make a lot more sense after that grade 12 calculus and vectors or whatever that course is called. Slope is connected to a calculus thing that you learn. Displacement is area. That's connected to a calculus thing as well. If I want to know how far this thing went in total for the whole 10 seconds that it was moving, I need to find the area of this trapezoidy shape. Some of you may have the area of a trapezoid memorized. I don't, so I'm going to go old school and break it into 2 parts. I've got the area of the triangle, and then I'm going to add on the area of the rectangle. Triangles are always 1/2 base height, and rectangles are always length times width. For the triangle, the base of that, it's not marked, but each line is 2, so the base is 2 seconds wide. And the height of it, it goes to a speed of 8. So we got 1/2 of 2 times 8. Then the rectangle, it goes from 2 to 10. So that's a length of 8 or width of 8, whatever you want to call that. But it's also 8 tall. So 8 times 8 for the rectangle. Little math, 1/2 times 2 times 8 is 8. 8 times 8 is 64. So adding those 2 numbers together, 64 plus 8 is 72. This object, whatever it is, moves 72 meters. If we wanted to get fancy, we could say that it moves 72 meters forward. That's how we break down VT graphs. And this one gave us all 3 pieces of information. The velocity information up here in black, telling us how fast it went. That's this. Acceleration information, I did that in purple, telling us basically by looking at the slopes. And then finally in red, we also get displacement information. I guess if we did it with displacement, we could do it with acceleration as well. the acceleration is 4 meters per second squared forward, since it was a positive slope.